topic for today is moles and equations. Now, in this topic, we will be mostly dealing with calculations. It's more mathematical than theoretical. So, it's really a breather in the paper, in the exam paper, because the questions are fairly very easy. You just need to know the formulas. So, before we move on to the mathematical part, it's important for us to know some definitions. So, the first up, we have isotopes. Isotopes are atoms of the same element with different number of neutrons. So for example, we have carbon 12. So in carbon 12, it's an isotope of carbon. We have 6 protons in the nucleus and 6 neutrons. So both these add up to give a nucleon number of 12. So this nucleon number is also called the mass number. So these add up to give a mass number of 12. Atomic mass number. And then the other isotope of carbon is carbon 13, which is so carbon 12 is the most abundant in nature, and carbon 13 is very little abundant. It's rarely found. So this has 6 protons. The proton number remains the same, but it has 7 neutrons. So it can be called an isotope because it has the same number of protons but a different number of neutrons. And the fact that it has the same number of protons suggests that it is an atom of the same element, because every element have their characteristic. Every element has its characteristic proton number. So for carbon, this proton number is 6, and that's what we call the atomic number. So the atomic number remains the same, 6. So because it has 6 protons, so the atomic number will remain the same. But since it has a different number of neutrons, in this case 7, in this case 6, then these are isotopes. And the third isotope of carbon is carbon 14, which is even rare. So carbon 12 is the most abundant, carbon 13 is a little less abundant, and carbon 14 is very less abundant. It is released from your body, it's radioactive in nature, and it is released from your body when you die, and it results in radioactive decay as after you've died. So carbon 14, this has 6 protons and 8 neutrons. Now 6 protons and 8 neutrons, again the proton number is the same, so it's the atom of the same element, but it has a different number of neutrons. Carbon 12 had 6, carbon 13 had 7, and carbon 14 has 8. So it has 8 neutrons this time, and hence it is also an isotope, atoms of the same element with different numbers of neutrons. So the next definition we have is relative atomic mass. It's the average mass of the atoms of the naturally occurring isotopes of an element relative to 1/12 the mass of a carbon 12 atom. Now, so many things are going on here. There's a lot happening over here. And now let's break this into parts and see what's happening. So first of all, it says average mass of the atoms of the naturally occurring isotopes. So we know that most elements do not have a single isotope. They have other isotopes as well. Not a single atom, they have isotopes as well. So for example, we saw carbon. For carbon, we saw carbon 12, 13 and 14. For hydrogen, we have hydrogen, deuterium and tritium. So these are all isotopes. This is 1 proton, no neutrons, 1 proton, 1 neutron, and 1 proton, 2 neutrons. So similarly for hydrogen, we have same proton number, different neutron numbers. So these are isotopes. So the average mass of these isotopes is relative to 1/12 the mass of a carbon 12 atom. So the atomic mass of a carbon 12 atom is taken as 12. So it is taken as a standard. It is taken as 12, the atomic mass of a carbon 12 atom. So 1/12 of this number. So 1/12 of this number 12 is 1. So 1 atomic mass unit. So basically, as I've written in the definition, atomic mass unit. So as I've written in the definition, the average mass of the atoms of the naturally occurring isotopes of an element relative to 1/12 the mass of a carbon 12 atom. So 1 by 12 the mass of a carbon 12 atom is at 1 atomic mass unit. So relative atomic mass is measured relative to this number, and for hydrogen it is 1, for helium it is 2, not 2, sorry, for helium it is 4. Helium, that the relative atomic mass of helium is 4, and so on. For lithium it's 6.9, for oxygen it is 16, for nitrogen it is 14, so on, it keeps going on like that in atomic mass units. So in the next slide we'll get to know how atomic mass is calculated, this relative atomic mass, using isotopes of the element. We will study about it, but for now we just need to know the definition. Then we have relative isotopic mass. So whenever we see this word relative, we just need to refer to this part of the definition, which is 1 by 12th the mass of a carbon 12 atom. This is a standard. The mass of a carbon 12 atom is taken as a standard. So we have to, so whenever we see the word relative, we have to say to 1 by 12th the mass of a carbon 12 atom. And then we are talking about isotopic mass. It is the mass of an atom of an isotope of an element. So a mass of an atom of an isotope of an element. So atomic mass was the average mass of the isotopes. Isotopic mass is of one isotope. So that's the difference between these two. Atomic mass refers to the average mass of different isotopes, which gives us the atomic mass of an element. And isotopic mass is the mass of a single isotope. So we will be using isotopic masses to calculate atomic masses. And you have to ensure that you write this part of the sentence, which is relative to 1 by 12th the mass of a carbon 12 atom, because of this relative over here. So relative molecular mass, it is the mass of a molecule of a compound relative to 1 by 12th the mass of a carbon 12 atom. So in this case we don't have an atom, we have a molecule. So for example, we have the carbon dioxide molecule, which has one carbon atom and two oxygen atoms. So the relative molecular mass, will be the sum of the relative atomic masses of all these atoms. So it will be the relative atomic mass of carbon plus twice the relative atomic mass of oxygen, because there are two oxygen atoms. So that will be the relative molecular mass. And again, you see the word relative, you see the phrase relative to 1 by 12 the mass of a carbon 12 atom. You cannot miss out on this. Then relative formula mass, it is the mass of one formula unit of a compound relative to 1 by 12th the mass of a carbon 12 atom. So it is technically the same as relative molecular mass, but it is used, the relative formula mass is used mostly for ionic compounds like MgCO3, and relative molecular mass is generally used for covalent compounds. So relative formula mass of MgCO3 will be the sum of relative atomic masses of Mg, of CO, of C, not CO, the sum of the atomic masses of Mg, C, and thrice the atomic mass of oxygen, because we have 3 oxygen atoms. So it's technically the same as the relative molecular mass, but it is generally used for ionic compounds, while relative molecular mass is used for covalent compounds, which are simple molecular compounds. Then mole. So the mole is basically a unit for amount of substance. It is a measure of an amount of substance, and it is defined as, so 1 mole of a substance is defined as the amount that contains the same number of specific particles as the number of atoms in 12 grams of carbon 12. So I will be emphasizing more on this definition as we get to the part of moles, of calculating moles. So just remember this definition for now, and I will come back to what it actually means. Then we have Avogadro constant. So Avogadro constant is basically a number 6.023